Move on to Dr. Erica Wagner, who is the Payload Sales Director at Blue Origin. We'll be speaking about New Shepard as a suborbital Lunar-g testbed.
Thanks so much, Maria. It's interesting to be in this section. We're more focused on our new capability with New Shepard for gravitational research, but wanted to introduce it to this community. Most of you know New Shepard for its work flying both payloads and tourists out of our West Texas launch site, doing frequent or ready return of missions up to the Kármán line and back. So I wanted to talk about a new capability we've been developing to enable partial gravity research on the same platform. Next slide, please. So our flight profile for New Shepard is a suborbital one. It goes up to the Kármán line at 100 kilometers and comes right back down, about an 11-minute flight from end to end. Our West Texas launch site is the world's only privately owned and operated launch and return facility, so it gives us a lot of flexibility for doing a wide range of missions in this space. What you see here is our flight profile, launch with a single BE-3 engine, about 2.5 minutes straight up into the West Texas desert sky and back down. The capsule separates at about 70 kilometers. Both the capsule and booster crest up over the Kármán line prior to return. And in that phase of the mission, we typically get about 3 minutes of really high quality, free-floating microgravity time for our experiments. The change here that we're offering and the upgrade we've been working on with the system and in collaboration with NASA STMD is to be able to take that central free-flying portion of the mission and use it as a giant centrifuge. So rotating the full capsule to create a centripetal acceleration in the payload ring. Next slide, please. As I said, New Shepard has been flying for a few years now. We've done 10 payload flights and 1 astronaut flight, which I hope you all had a chance to see last month. A really exciting milestone for us. Those flights have carried more than 100 payloads for 7 different countries, up and back, and including a large portion, more than 40 payloads for the NASA Flight Opportunities Program. And I'll talk more later on about ways of accessing research dollars to come fly with us. Next slide, please. So here you see a sort of transparent view of our crew capsule. 6 stacks of payloads oriented in a ring around that central pillar. Each stack of payloads carries 6 lockers, about the size of a mid-deck locker on space shuttle or space station, if you're familiar with that standard, about the size of a small dorm microwave, and 25 pounds of payload if you're less familiar. The nice thing about these stacks is that they've all provide interfaces to the payloads with power and data and other services. So really what you're focused on is just what's going inside your locker box. Next slide, please. We have standard interface sizes that make it simpler to develop payloads. We're also happy to work with anyone who has sort of more custom needs. But here you see that single locker, 25 pounds, the double locker about the size of a small refrigerator, 50 pounds of payload, and the full stack, which replaces a seat in the capsule with up to 150 pounds of payload mass. For our microgravity flights, we also offer small 2U mini payloads, mostly for student uses. That's a little bit less applicable here for the partial gravity flight. Next slide, please. Okay, so let's get into the meat of this. What you see here is the partial G mission concept, and these upgrades are underway right now in our crew capsule development. The capsule is spin stabilized after separation using our reaction control system thrusters. Normally, we would spin stabilize to a 0 or very slow rate of rotation. In this case, we're going to spin stabilize to about 11 RPM to create that Lunar-g circumferentially in the cabin. There is a variety of radii at which you can place your payloads within that ring, sort of about 1 meter to 1.5 meters, giving you an opportunity to explore not just Lunar-g, but also sort of the delta and sensitivity around that G set point. We provide power and data and compute to those lockers, so again, letting you focus really on the science that's going inside. And we've been talking with NASA about the possibility of architecting future missions using the same capability to spin at different rates, allowing us to explore a wider range of G transitions, G sensitivities. Next slide, please. So what are investigators doing in this first mission? So we are currently manifesting a flight in early 2023 with NASA STMD to allow us to explore this Lunar-g range. We're seeing a lot of interest in maturation of surface hardware, including things like multi-phase flow, thermal management, and even things like deployable structures are possible in this regime. On the physical sciences, sort of traditional BPS side, flammability and fire safety, some very provocative results coming out of the NASA Glenn drop towers showing enhanced flammability of materials in a partial G regime with both convection and diffusion limited flames. Flow boiling and the way that we're looking at multi-phase flows, particularly transitions that are hard to model because of their nonlinearities. And of course, those have applications to life support systems, cryogenic fluid management, thermal radiator systems, and propulsion. Regolith handling and dust mitigation, regolith management, ISRU, all of those granular physics become very interesting at partial G regimes and very difficult to simulate in a parabolic aircraft flight because of that continuous push-pull between high G and low G. So being able to get a couple of minutes at a stretch of a partial gravity environment, very interesting in this capability. Next slide, please. So if this is something that's of interest to you, how do you access it? So I'm going to drop my email into the chat thread here. So that's a first thing is if you have questions, please feel free to reach out to my team and I. There are multiple solicitations that are open to funding capabilities on the New Shepard rocket through NASA, as well as other agencies. The STMD Space Tech Ready solicitations, particularly Ready Tech Flights, which is open right now, a very targeted solicitation for suborbital research. The STMD Tipping Point solicitation, something that's really quite interesting for doing larger format studies, multiple test flights, and more aggressive technology maturation. On the SMD side of the house, with biological and physical sciences being incorporated into the ROSES campaign, that is definitely the right home for exploring suborbital flights. And we've now seen SMD making a concerted effort at opening up those doors, not just to traditional sounding rockets, but also to the commercial platforms like New Shepard, and making that road even easier for investigators who find this to be a relevant capability. For those who are small businesses or work with small businesses, we've seen a lot of good work with SBIR, STTR portfolios, phase 2 grants and 2E and 2X extensions, all a good fit for these flights, coming in at a couple of $100K is a good starting point for a budget. And of course, a lot of other solicitations around here that you can fit into. The interesting thing about the commercial model, of course, you can put us into any solicitation. It doesn't have to be a targeted solicitation for suborbital. You could imagine an ISS solicitation where this is a technology maturation step, a CLIPS solicitation or a lunar science solicitation where this is buying down risk for those applications.
1 minute.
Slide, please. Thank you. So just to close out, here's a picture of one of our missions with a bunch of our research community down in West Texas. It really is amazing to go from watching the rocket roll out at dawn to that afternoon standing on the pad and seeing the vehicle that just took your science to space. So we're looking forward to extending that not only to the microgravity and high altitude communities, but also those of you who are interested in lunar and partial gravity work. And with that, I give you my thanks.
Thank you, Dr. Wagner.